Hello data leads, and welcome to the first April Synchronous session. During today's session, we'll be covering two main learning objectives. The first is that you will learn about specific data cleaning considerations for CCMR data. The second is that you will learn the foundations of data analysis and storytelling and how each of these support CCMR outcomes bonus work. In the first section today, we're going to be revisiting data cleaning practices and discussing some CCMR specific considerations. As a reminder, data cleaning is a process of fixing or removing incorrect, corrupted, incorrectly formatted, duplicate, or incomplete data within a dataset. You may assume that data will right away be cleaned, but don't be fooled. When combining multiple data sources, there are many opportunities for data to be duplicated, mislabeled, or incorrectly deleted. If data is incorrect, outcomes and algorithms are unreliable, even though they may look correct. The front-end data work is a much bigger part of data analysis and visualization than most people realize, but it truly is the foundation of your house and not an area to skimp on. If we have dirty data, aka garbage, coming in, the only thing that the dashboard will produce is inaccurate data or garbage. So garbage in, garbage out. While there is no one absolute way to prescribe the exact steps in data cleaning process, because the processes really vary from dataset to dataset, we do have a list of steps that should be considered. While not each step may need to occur in your dataset, it's important to consider each. The data cleaning checklist is a resource that we have created for you to do just that. This was included in your workbook during the March Synchronous session and is available on the Data Lead Hub. As a reminder, we also worked through these steps in the March Synchronous session. So if you need a refresher, please check out that recording on the Data Lead Hub. In terms of CCMR specific data cleaning considerations, we want to highlight a couple pieces. The data has been coming out pretty clean, but there are still a couple points we want to highlight. The first is to ensure that you have access to the Excel or CVS PIMS reports. Frequently, they're downloaded as a PDF, but you'll need to have them downloaded as a CSV file, as these can be opened in Excel. The second consideration is formatting. Ensure that each file only includes one row of headers or titles, and the rest of the rows are filled with the actual data. If there are any empty columns, ensure that you delete these. This will allow the file to be uploaded properly. The third consideration is ensuring that you have a common identifier in each of the files. In the best case scenario, there should be a unique student ID in each file. This will allow you to create one larger data set. Student names alone are not adequate, as frequently there are more than one student with the same first and last name. So ensure that the student ID is in all of those files. The second session today is going to focus on data analysis and storytelling. As a primer for today's discussion, we wanted to read a quote from an article in the Harvard Business Review. The article does a great job laying out the role of a data scientist and the importance of curiosity-driven work. As I read the quote, think about your role as a data lead and remember why you're in this role. More than anything, what data scientists do is make discoveries while swimming in data. It's their preferred method of navigating the world around them. At ease in the digital realm, they are able to bring structure to large quantities of formless data and make analysis possible. They identify rich data sources, join them with other potentially incomplete data sources, and clean the resulting set. In a competitive landscape where challenges keep changing and data never stops flowing, data scientists help decision makers shift from ad hoc analysis to an ongoing conversation with data. Data scientists really realize that they face technical limitations, but they don't allow that to bog down their search for novel solutions. As they make discoveries, They communicate what they've learned and suggest its implications for new business directions. Often they're creative in displaying information visually and making the patterns they find clear and compelling. They advise executives and product managers on the implications of the data for products, processes, and decisions. Data scientists' most basic, universal skill is the ability to write code. This may be less true in 5 years' time, when many more people will have the title data scientist on their business cards. More enduring will be the need for data scientists to communicate in language that all their stakeholders understand, and to demonstrate the special skills involved in storytelling with data, whether verbally, visually, or ideally both. But what we would say the dominant trait among data scientists is an intense curiosity, a desire to go beneath the surface of a problem, find the question at its heart, and distill them into a very clear set of hypotheses that can be tested. To start our discussion on data analysis, we're going to discuss exploratory data analysis and the role it plays when reviewing and analyzing data. Exploratory data analysis, or EDA, is used to analyze and investigate data sets and summarize their main characteristics. EDA assists in discovering patterns, spotting anomalies, testing hypotheses, and checking assumptions. It's also important that we review some key concepts associated with EDA. To exemplify these concepts, let's read this quick passage. There are 125 students enrolled at Claudia's school. She is interested in understanding the socioeconomic status of 3rd and 4th grade students who make up 49 of the 125 students. In this scenario, the 125 students enrolled at the school are the population, or the group of all the cases being studied. The socioeconomic status of the students is the variable, or the characteristic of interest. The 3rd and 4th grade students are the sample, or the subset of cases that are used to study a population as a whole. And lastly, the 49 students, those 3rd and 4th graders, make up the sample size. This is the number of cases in your sample. Another important set of key concepts related to EDA that are important to understand are the various levels of measurement. Different variables in your dataset may have different levels of measurement, which will affect the type of analysis that you're able to do. Levels of measurement differ in the amount of precision needed in the measurement. Less precise levels of measurement restrict what you can do with the data. Let's explore the various levels of measurement using a coffee menu example. First is the type of coffee drink, which is a nominal or categorical variable. This level of measurement categorizes your data by labeling them in mutually exclusive groups, but there is no order between the categories. Next is the size of a drink. This is an ordinal measure. You're able to categorize and rank your data in an order, but you cannot say anything about the intervals between the rankings. Next is the temperature of your coffee, which is an interval measure. You're able to categorize, rank, and infer equal intervals between neighboring data points, but there is no true zero. And lastly is the price of coffee, a ratio measure. With this measure, you're able to categorize, rank, and infer equal intervals between neighboring data points, and there is a true 0 point. A true zero refers to a scale where 0 indicates the absence of something. An interval scale lacks a true 0. Examples of scales without a true 0 include rating scales, temperature, and measures of latitude and longitude. Presented here is a diagram that shows the characteristics of each level of measurement, from nominal to ratio. And you can see that nominal only has those named categories, where ordinal also has a natural order. Interval builds upon ordinal, and it includes an equal intervals between variables. And then lastly is ratio, which includes a true 0 point. When discussing data analysis, It's also important to discuss the difference between inferential and descriptive statistics. Inferential statistical tools are used to draw inferences about a population based on the data in your sample. For example, what might the population overall think about something based on sample responses? With inferential statistics, you're trying to reach conclusions that extend beyond the immediate data alone. Descriptive statistical tools are used to describe properties of data in your sample. These include frequencies and percentages, central measures of tendency, distribution, and variance. In your role as a data lead, we'll be focusing more on descriptive statistics. This is what is going to make the dashboard different from a report that you're able to pull from a learning management system or from your student information system. It will help you identify the patterns from multiple data sources instead of relying on human eye to identify patterns. This diagram is used to summarize the three major types of descriptive statistics and help you in deciding what measure to use to summarize your data. To use the diagram, start by answering the question, what do you want to see from your data? Do you want to see how scores are distributed across different values in your data? If that's the case, you should present either a frequency or a percentage. Do you want to show how scores on a variable differ from one another? If that's true, and if you have an interval or ratio variable, you should present a range. If you want to show a representative score for your data, do you want to show a central score or the score that occurs the most? If you want to show the score that occurs most often, you should present the mode. Also, as a caveat, or if there are multiple modes, you should also instead consider presenting the frequency or percent. If the representative score that you want to present is a central score, you must first determine what type of variable you have. If you have a nominal variable, a central score cannot be presented. Remember, a nominal variable is only a category and doesn't have a meaningful order. Therefore, you will either present a mode, or again, if there's multiple modes, present the percent or frequency. If you have an ordinal variable, you can present this using the median. However, if there are few data points and a few data points that fall in the center of your data, you should consider using the percent or frequency, as it will provide more substantive information. Lastly, if you have an interval or ratio variable, you can present the mean. However, if the data are skewed, meaning that they don't fall along a typical bell curve, you should instead consider presenting the median, as this will account for any outlier data points that pull the mean higher or lower, resulting in a data point that misrepresents the data. Presented here are three visualizations showing descriptive statistics to highlight their use in analyzing CCMR data. The first line chart is presenting the percent of students by subpopulation who are meeting outcomes bonus criteria. This percentage is compared by year. This allows us to look at how the frequency varies both by subpopulation as well as by year. The second line chart presents the average TSIA score by subject. Again, the average score is presented by year. The third bar chart is showing us the frequency of industry-based certifications earned by graduating class over the last 3 years. These aggregate summaries of data provide us a really great starting point in understanding what's going on in our data, or with the student CCM readiness. Now we're going to jump from analysis into data storytelling. So what is data storytelling, and why is it an important skill as we prepare to create a data dashboard? In the simplest of definitions, data storytelling is taking numbers and translating them into a language and story so that everyone can understand. It's communicating data in a clear and compelling way. As stated by Stephen Few, numbers have an important story to tell, but they rely on you to give them a clear and convincing voice. So rather than presenting your team with a spreadsheet of data and rattling off numbers, consider how you can engage multiple parts of their brains. Through data storytelling, you can invoke an emotional response on a neural level that can help your points be remembered and, most importantly, acted upon. When neuroscientists observed the effects data had on an audience, brain scan revealed it only activated 2 areas of the brain associated with language processing. However, when someone is absorbed in a story, they discovered that it stimulated more areas of the brain. So people hear statistics, but they feel stories. Too often, data storytelling is interpreted as just visualizing data effectively. However, it is much more than just creating visually appealing charts and dashboards. Data storytelling is a structured approach for communicating data insights, and it involves a combination of 3 key elements: data, visuals, and narrative. Each component plays an important role on their own, but the true magic comes when they're all applied together. The first component of data storytelling is the narrative, the verbal or written storyline that's used to communicate insights gleaned from the data, the context surrounding it, and actions that you aim to inspire in your audience. The second component are visuals. These are the visual representations of your data, including charts, graphs, diagrams, and pictures. The third component are the data. The data is the foundation of your data story. The analysis of data enables you to understand the full picture. When narrative is coupled with data, it explains to your audience what's happening in the data and why a particular insight is important. Context are needed to fully appreciate an insight. When visuals are applied to data, they can enlighten the audience to insights that they wouldn't see without charts or graphs. Many interesting patterns and outliers in the data would remain hidden in the rows and columns of data tables without the help of data visualization. When narrative and visuals are merged together, they can engage or even entertain an audience. And when you combine the right visuals and narrative with the right data, you have a data story that can influence and drive change. The brain's preference for stories over pure data stems from the fact that it takes in so much information every day and needs to determine what's important to process and remember and what can be discarded. Data storytelling uses the same narrative elements as any story that you've read or heard before: characters, setting, conflict, and a resolution. Freytag's pyramid, depicted here, describes the 5 key stages of a story, offering a conceptual framework for writing a story from start to finish. In the next portion of the webinar, we're going to walk through the steps of crafting a compelling narrative. After each definition of the step and what it entails, there will be an example slide. We've also created a template data story slide deck for you to use. This will be shared with this email and is available on the Data Lead Resource Hub. The first step on Freytag's pyramid is the exposition. The exposition presents the important background information that helps set the stage for the story. Think who, what, where, and when. The exposition ends with the inciting incident, when something unexpected happens. Here's an example slide that presents an exposition, or the background of the story. You'll notice that the slide isn't overwhelmed with information and text. It's important to keep the slide simple, allowing for you to supplement the slide with the narrative. In this example, we present a bar graph that is comparing student participation in a tutoring program by MAP, the percent of students scoring at grade level on the MAP math assessment in spring 2021. The slide also includes a 1-sentence summary that highlights the key takeaways from the graph: that a larger percent of students in the tutoring program scored at grade level when compared to those who did not participate. The narrative that would be used to supplement this slide could be something like, 2 schools at Longhorn ISD, Badger and Spartan Elementary, began implementing a high-dosage math tutoring program during the 2020-21 academic year. The district utilizes the NWEA MAP assessment as its interim assessment and reviewed the spring data to better understand the effectiveness of the tutoring program. The percentage of students who scored at grade level in the spring 21 MAP math assessment was higher for students who participated in the tutoring program when compared to those who did not at each grade level. As previously stated, the exposition always includes with the inciting incident when something unexpected happens or is noticed in the data. Here's an example slide presenting this point in the story. In this example, we present again a bar graph, but this time it's comparing student participation in a tutoring program by the percent of students scoring at grade level on the MAP math assessment in winter 2022 by campus. The slide also includes a one-sentence anecdote that highlights the key takeaways from the graph. That a similar increase in students scoring at grade level was not observed at Gator Elementary. The narrative that would be used to supplement this slide would be something like, after Gator Elementary, another elementary school within Longhorn ISD, saw the impact the tutoring program was having at Badger and Spartan Elementary, they decided to implement the same program beginning in the 2021-22 school year. After the first semester of the year was complete, the team reviewed the most recent MAP assessment results from winter 2022. The data showed that Gator Elementary did not experience similar increases in the percent of students scoring at grade level when compared to Badger and Spartan elementary schools. The next step in Freytag's pyramid is the rising action. This is the series of insights that are found through data analysis. This part of the story investigates the story's plot and provides the audience with key pieces of the backstory. Here is an example slide presenting this point in the story. In this example, we present the program process data that was collected from each school during the first semester of the 21-22 school year. The donut charts on the left show overall the percentage of students who are attending programming as planned, which is defined as a student attending at least 3 tutoring sessions a week, totaling at least 90 minutes, and with groups of less than 5 students. The bar graphs on the right present each of those program metrics. The slide also includes a one-sentence anecdote that highlights the key takeaway from the visuals. Differences were identified between campuses in the percent of students who attended the tutoring program as planned. The narrative that would be used to supplement this slide could be something like, when the team reviewed the program process data from semester 1, differences were identified between campuses in the percent of students who were attending the program as planned. Gator Elementary had a lower percent of students who attended the program as planned. The next step in the pyramid is the climax. The climax is at the top of the pyramid and is the turning point in the story. It provides an overview of the conclusions that were drawn from the exploration and details the expected outcomes or consequences if no changes are made. Here is an example slide presenting this point in the story. In this example, we only include text highlighting the key takeaways from the exploration or data analysis and potential consequences if no changes are made. The narrative that would be used to supplement this slide could be something like, when the team reviewed the program process data from semester 1, differences were identified between campuses in the percent of students who were attending the program as planned. The program is not being implemented with fidelity at Gator Elementary. Specifically, only 50% of students at Gator attended at least 3 days of programming a week, and only 45% of students attended 90 or more minutes of programming a week. If changes are not made, we can expect to see similar results for Gator Elementary on the spring 2022 MAP assessment, or a lack of growth in the percent of students scoring at grade level. In addition, due to the requirements of the program and funding, Gator Elementary may lose the program funding if at least 75% of students are not participating in the program as planned. After the climax comes the falling action, or the determination of how to address the identified issue. During this portion of the story, the aftermath of the climax and options for long-term solutions are explored. The story asks, what is the best immediate action to take based on a pros and cons comparison? Presented here is an example slide presenting this point in the story. In this example, we again only include text, highlighting the key steps that have already been taken and the determined next action steps. In this example, the team already engaged in the process of analyzing the data and determining the next steps. However, it could be at this point that this is a stopping point during your presentation, and during this time you engage your audience in a discussion around what the data are saying and what next steps should be. The narrative that could be used to supplement this slide could be something like, after identifying the lack of academic achievement at Gator Elementary, the Semester 1 program data in fall 2021 and winter 2022 MAP math data were presented to program staff and principals of the 3 elementary schools in February 22. The group engaged in a facilitated discussion around the data and concluded with discussing the best strategies to address. The team determined that the following actions would be taken to address the issue. The program process data would be reviewed weekly on Monday, reflecting the previous week's data. In addition, students not participating in the program as planned will be flagged in the data system. The team will also review the outcome results report for math courses in Canvas, the district's learning management system, bi-weekly. This will assist in monitoring student mastery of key math concepts and provide more insight on student academic achievement between local assessment periods. The team will also disseminate the program process protocol to each campus, ensuring there's an accurate understanding of program participation requirements and what can happen if 75% of students are not participating. Lastly, the team will continue to review MAP assessment data following the fall, winter, and spring assessment periods. The last point in the story is the resolution, the expected outcome after resolving the issue in the denouement, when the final strands of the plot are drawn together and all issues are resolved. Presented here is an example slide presenting the story resolution and denouement. In this example, we again only include text, highlighting the expected outcomes and how the team will prevent this from happening again. The narrative that would be used to supplement this slide could be something like, after implementing the identified action steps, the team expects that at least 90% of Gator Elementary students will participate in the tutoring program as planned, and that a higher proportion of students who participate in the tutoring program will score at grade level on the spring 2022 MAP math assessment when compared to non-participants. The team also shared how they will prevent this from happening again, reiterating the next steps that will be taken. These include that the program process data will be reviewed weekly, informative assessment data will be reviewed in Canvas bi-weekly as a team. In addition, the program process protocols will be disseminated, and the MAP data will continue to be regularly reviewed. In terms of what you should be working on now, between now and your April individual meeting, please focus on collecting the data points that were outlined in the March Synchronous webinar. As a reminder, these include the CCMR Tracker, CCMR Verifier, Industry-Based Certification, Associate Degree, Dual Credit Course Completion, FAFSA completion rates, College application completion rates, military enlistment data, and TSIA readiness. The source for each of these data points are presented in this table, along with the years of data that you should be collecting. Our goal is that you will have this data collected by your April individual meeting. Once you have collected the data, please begin cleaning each file using the previously shared data cleaning checklist. As a reminder in the overall program timeline, that's presented here, along with specific milestones. As previously stated, our goal is that you have all of the data collected by your April individual meeting. In May, we'll have 2 individual meetings. Our goal is that you will have uploaded the collected data into the data visualization template that we will share with you by the first May individual meeting. By the second May individual meeting, our goal is that you will have entered your data into the template strategic planning slide deck that we will be sharing. To summarize what we just reviewed as to what you should be working on now, first, ensure that you've scheduled your April one-on-one session. Second, work on collecting all of the required data by your April one-on-one. And third, once collected, begin cleaning each of the data sets. In looking ahead in April, we will have your April one-on-one session. A second asynchronous session will be published next Monday, April 10th, and our office hours will be hosted on April 25th from 1 to 2 p.m. Thank you for listening. Please complete the linked exit ticket so that we can document that you completed this session. This also provides us with important feedback to improve the sessions and materials that we provide. As always, reach out with any questions. Thank you.